In today's video, we're going to look at two ways of solving a quadratic. Now, first of all, a solution to a quadratic can be referred to as a root, a zero, or x-intercept. Now, there can be more than one. For instance, let's say a quadratic crosses the x-axis at 2 points. Those x values where it crosses, those x-intercepts, are your solutions. So this one has two solutions. If a quadratic only touches once at the vertex, there's one solution. If the graph never touches the x-axis, there is no real solution. Now, solving quadratics by graphing is pretty simple. Basically, just graph the quadratic and look to see where it crosses the x-axis. So, for instance, let's take x squared plus 2x minus 3. So you want to graph it. Now, I've talked in other videos about how to graph quadratics, so I'm not going to go back over that. For now, all I'm going to do is use the graphing calculator to graph it, look at the table, and I need it centered. Obviously right now it's not centered, so I'm going to go up here, and there we go. So I'm going to plot these points. So I get -4, +5, 3, 4, 5 right there, -3, 0, -2, -3, and then, ooh, got carried away there. Alright. Now, when I look at this, there are two places it crosses the x-axis, here and here. Those points, which are -3 and 1 on the x-axis, are your solutions. If a graph only crosses the x-axis once, there's only going to be one solution. So let's take, for example, -x squared minus 10x minus 25. And again, I'm just going to use the graphing calculator. There are ways to do it without it. I'm just going for the quickest. And you are going to plot your points. Now, you don't need that many points. So 2, 4, 6, 7, -4. Again, I'm just using the table here to graph it, and I'm not even doing all of them. I'm just doing a few. So -6, -1, -5, 0, and honestly, that's good enough. I don't need to have every point to be able to answer or find the solution. In this case, there's only one solution here, where x is -5. And of course, there can be no solution, or no real solution at least. So give you an example of that. Let's say y equals -x squared plus 8x minus 17. So -x squared plus 8x minus 17. Okay. Oh, too far. I went the wrong way. Alright, that's good enough. So 2, -5, 2, -5, and let's see, 3, -2, 4, -1, and then it goes back down. So this graph is never going to touch the x-axis, which means there is no real solution. Later I'm going to be talking about what are called imaginary numbers, which are solutions to problems like these. For now though, I'm going to move on to another method of solving quadratics, which is called factoring. Now, factoring is something we have done in Algebra 1. I'm going to review a couple of little things. First of all, always look for a greatest common factor. So for instance, if I wanted to factor, let's see, 12k squared minus 18k. There's a greatest common factor here of 6k. Both of these terms are divisible by 6 and by k. So I can rewrite this as 6k times 2k minus 3. Now you might be asking, how did I get the 2k and minus 3? Well, what you do is you divide both of these terms by the greatest common factor. We take the greatest common factor, put it out front, and what's left over when we divide goes here. Okay. Now, sometimes you'll get what are called trinomials that you have to factor. And I'm going to show you different cases. The first, trinomials are written as ax squared plus bx plus c. And I'm going to show you two different cases. One where your a value is equal to 1, and also where your a value is not equal to 1. So, what I'm going to do, okay, I'm going to start with, let's see, trying to think of one that would be pretty good. Okay, let's start with a squared plus 12a plus 36, and I want to factor that. And I'm going to go ahead and show you how to solve. Actually, no, I'm going to do just factoring first, and then I'll show you how to use that to solve later. Okay, so let's say I wanted to factor this. The first thing you do is you multiply your a and c terms. A is in front of your squared term, c is by itself. So 1 times 36 gives me 36. Now I want two numbers that will multiply to give me 36, but add to be 12. So what I do is I go through and I list factors of 36. Now we're adding to be a positive number and multiplying to be a positive number, so my factors are both going to be positive. So I could multiply 1 and 36, but that does not add to 12. 2 and 18, but again, it doesn't add up to 12. And you can list whatever factors you think of, or you can jump straight to the end. So I can do 4 and 9, or I can just jump to the 6 times 6. Now, 6 times 6 gives me 36, but add to be 12. So those are the numbers I'm going to use. So basically what I'm going to do is I'm going to write this as a plus 6, because it was a positive 6, times a plus 6. Which, because this is the same binomial, I can write as a plus 6 squared. Now it's not always going to be like that. Let me show you another example. Let's say I have okay, c squared plus 2c minus 48. You start the same way. You multiply your a and c terms, so 1 times negative 48 gives me negative 48. So now I'm going to start listing factors of negative 48. Now, it needs to be multiplied to be negative 48, but add to be positive 2. That means one's going to be positive and one's going to be negative. And the bigger one is going to be the positive because it adds to a positive number. So, for instance, negative 48. I could multiply negative 1 and positive 48, but that's not going to give me positive 2. Not when I add. It could be negative 2 and 24, but again, it does not add to 2. The ones that will add to 2 are negative 6 and positive 8. Now there's more factors I haven't done, but these are the ones that you're looking for. So my factors are going to be C minus 6, because we have a negative 6 here, and C plus 8. Now I'm going to come back to these a little later and show you how to use that to solve. So both of those had an A value of 1. But what happens if you have something other than a 1 in front of your A squared? Well, what you're going to have to do is, well, I guess it's going to be easier just to show you. So let me give you an example. Let's take 2x squared minus 15x plus 18. Okay. In this one, our number in front of x squared is not 1, and it's not going to factor out because 15 is not divisible by 2. What you're going to do is you're going to start by multiplying your A and C terms, which is what we did before. It's just that the A term was 1, so it didn't really change your C term. But we are going to be multiplying these two numbers. So when I multiply A and C, 2 times 18, 2 times 18 is going to give me 36. It's the 36 that I'm going to factor, or find factors of. And just like before, we want factors of 36 that will add to be negative 15. So let's take so two numbers that multiply to be 36. Let's see, 2 and 18, 3 and 12, 3 and 12. Well, 3 and 12 had to be 15, but we need it to be negative 15. So it's negative 3 and negative 12. Negative times negative gives me positive 36, but add to be a negative 15. So this means when I did the others, I wrote it as these two binomials. But there's one problem. If I were to check myself by foiling, remember first, outside, inside, and last, I'm going to get x squared, not 2x squared. It's not going to come out to be the same value that I have in my original expression. What you have to do is incorporate that 2 in. So instead of dividing it out at the beginning, which is what we would do with the GCF, we're going to divide it now. So at this point, I'm going to take and divide both of my numbers here by 2. So the next thing is I'm going to reduce. 3 halves doesn't reduce. I guess I should have moved that up a little bit. Oh well. But 12 halves does. It reduces to 6. Now, technically, we're still not, if we were to FOIL at this point, we're still not going to get that 2x squared minus 15x plus 18 until we rewrite this part here. What I'm going to do is I'm going to take the denominator here and put it in front of the x, which is going to give me 2x minus 3 times x minus 6. And you can check yourself if you're not sure. One way you can check yourself is to put this into y1, this into y2, and then graph it to make sure you only get one line, or you can look at the table and see. Another way to check it is by foiling. So I'm going to go over here, 2x minus 3 times, x minus 6. If I were to FOIL this back out, I'm going to get 2x squared minus 12x minus 3x plus 18, which becomes 2x squared minus 15x plus 18, the same as what I had at the original. So this checks out. Now, there are other trinomials which are called perfect square, or I'm sorry, difference of squares. So, a difference of squares is when you have two perfect squares that are being subtracted. And you can write it like this. Basically what you do is you take the square root of both terms, add those in one, subtract them in the other. So for example, I might have x squared minus 25. X squared and 25 are both perfect squares. The square root of x squared is x. The square root of 25 is 5. So I can write this as x plus 5 times x minus 5. Now let's say you forget this rule. You can factor it like we did the previous ones. I need to multiply your a and c terms. I get 25. Two numbers that multiply to be 25 but add to be 0 because there is no x term are negative 5 and 5. Negative 5 and 5. So you can factor it like you did the others if you forget your difference of squares rule. Now, one more thing though, you do need to be careful about factoring out your GCF if you have one. So, for instance, let's say we had 3x squared minus 12. That's not a difference of squares right now, until you factor out the 3. The GCF, once you take it out, leaves us with x squared minus 4. So now it's a difference of squares. Square root of x squared is x, square root of 4 is 2. So x plus 2 and x minus 2. This is the factored form of this. Now, I'm going over this because you can use factoring to solve a quadratic. To use factoring to solve a quadratic, you first want to make sure that all your terms are on one side and set it's equal to 0. If there's a GCF, take out the GCF, factor what remains. Then you set each factor equal to 0 and solve for the remainder. So let's go back and look at the ones I've already factored. Let's say that this was my equation and I had it equal to 0. That means this is equal to 0. Now, because we're multiplying these, if even one of these factors is equal to 0, the whole thing becomes equal to 0. So what I'm going to do is I'm going to take a minus 6, set it or a plus 6, I'm sorry, equal to 0, and solve for a. So if I were to plug in a negative 6 into this equation, I'm going to get a 0, and that's the solution to the equation. So let's test it out. Negative 6 squared plus 12 times negative 6 plus 36 gives me 0. It checks out. Negative 6 is a solution. But remember that many quadratics have more than one solution. Like this one is going to have more than one solution. And let me rewrite that. There we go. So what I'm going to do on this one is take both, if it's equal to 0, if I'm actually solving. Before I just was factoring, now I'm actually solving. Once you have it factored, you set each factor equal to 0 and solve. So here I would add 6 to both sides to get c equals 6 for one of the solutions. And here I would subtract 8 to get c equals -8 for the other solution. And again, you can test it out by plugging them both into this original equation to see if it checks out. The same thing can be done for the other ones I factored. Now I'm going to do one more just from scratch to show you the steps from beginning to end. Let's see. Okay, so let's take 3x squared minus 13x equals 30. The first thing we want to do when solving by factoring is make sure everything is on the same side and is equal to 0. So I'm going to start by subtracting 30 from both sides. Now this 3 is not going to factor out. So I'm going to go to the next step, which is to multiply your a and c term. 3 times 30 gives me, 3 times -30 gives me -90. So I'm going to factor this. Now let's say you aren't sure what numbers will multiply to be 90, or maybe the only ones you can think of aren't adding to be the -13 that we need. You can, if you have a graphing calculator, you can use it. If you type in the number divided by x and look at the table, you can see what numbers multiply to give you that value. So I need it to multiply to be -90 but add to be -13. So when I look at this, 5 times -18 will give me -13. So x plus 5 times x minus 18. But again, because this is one of the ones that had an a value not equal to 1, there's an additional step we have to do before it's fully factored. And that's divide by the 3 up there. Now, x plus 5/3 is not going to simplify, and x minus 18/3, well, that does reduce to 6. Now technically this isn't fully factored, but I am solving here, not factoring. So instead of rewriting this one as 3x plus 5, I'm going to leave it as is, because I can go ahead and just use it the way it is. Take the x plus 5/3, set it equal to 0, and subtract 5/3 from both sides, which gives me -5/3. Now I could have rewritten this as 3x plus 5, set that equal to 0 and solve, but I get the same answer. So if I'm solving, I'm not going to bother rewriting it because it's just going to make me undo what I just did. So continuing, finishing the problem here, take the other factor, set that equal to 0, add 6 to both sides, and you get your other answer, which is +6. Alright, so again, two ways you can solve a quadratic are by graphing and by factoring, and that's what we've got covered here.